So one common strategy that's often used is you optimize your hyperparameters using a small network, and then use those hyperparameters to train a large network. So this is cost effective because you're mostly training small networks. But unfortunately, it does not always work. And in particularly with sparse networks, we found this strategy does not work. The parameters that you got from training a small network did not always translate to a large network. So what we did is we used SigOpt's multitask optimization feature. And what you can do there is set up a number of different tasks, and SigOpt will allow you to associate a cost with each of these tasks, and then we'll try to optimize how many, which tasks are run with the goal of reducing the overall cost of running these things. And so our strategy was to always run a large network, but with a varying number of training steps. So you can see on the right, another screenshot from their dashboard. I set up a 3-task system. So we train the network for 15 epochs. That's a cost of 0.25, 30 epochs, or 60 epochs, which is the full cost training. And by balancing between these different tasks, we're able to actually get state-of-the-art accuracy in a cost-effective manner. And again, what we found is that the hyperparameters for sparse networks were pretty different, again, for dense networks. So this was definitely a worthwhile thing to do. This chart kind of shows the kind of how this works in SigOpt. The gray dots show the runs that were at the lower cost tasks, and the blue circles show the trials that were run at the higher cost, and those obviously have higher accuracy. And you can see that most of the runs were done at the lower cost scenarios, and then once it starts to hone in on some parameter regimes, SigOpt will automatically invoke the higher cost regime. So again, this allowed us to achieve state-of-the-art accuracy in some of our networks in a very cost-effective manner.